Hello, class. My name is Fred, and last week I met with Savina and Mark to talk a bit about synapses. My synapses are a bit special because I have epilepsy. I take Retigabine to help my seizures. I'm not quite sure what happens at a synapse, but Savina and Mark do, so I'll show you what they showed me last week. Now pay attention.
The action potential propagates down the axon on the presynaptic neuron.
The local membrane potential depolarizes and causes an influx of calcium through the voltage-gated calcium channel because the intracellular concentration of calcium is much lower inside the cell than outside the cell.
The calcium then binds to synaptotagmin on the vesicles and readies the vesicle for fusion with the membrane. Snare proteins pull the vesicle and the membrane together, causing the vesicle to fuse to the membrane and release excitatory neurotransmitter, glutamate, into the synaptic cleft.
The neurotransmitter then binds to the AMPA receptors on the postsynaptic spine. This causes the channel to open and sodium to enter. The influx of sodium results in a slight depolarization.
Upon more binding of neurotransmitter to AMPA receptors, the postsynaptic neuron will begin to depolarize and thus allow for the removal of the magnesium ion to unblock the NMDA receptors.
NMDA receptors are known as coincidence detectors because they will only be open when both the neuron is strongly depolarized and neurotransmitter is bound. An epileptic episode is categorized by uncontrolled and continuous firing of neurons, which will result in a seizure.
A new drug, Retigabine, has been used as an anticonvulsant by opening voltage-gated potassium channels. The opening of these channels causes an efflux of potassium due to the concentration gradient, helping to hyperpolarize the cell. This amplifies the natural inhibitory mechanism that prevents the high levels of neuronal activity, thus inhibiting the propagation of seizures.
Oh, I feel better now. Okay, so I will see you next week, okay? Okay.